Sound ಕಡಿಮೆ ಇಡು ಅಂತ ಅವಾಗಿಂದ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. Yeah, good morning. We'll start with the lesson. In our last class, we are discussing on internet networking, that is the IP protocol, and that from beginning we are discussing that what is the importance of an IP protocol in a heterogeneous network of this internet, where different combinations of a network has been connected, and how a IP protocol will transfer the frames, whatever it has been collected from one network to the other different network, based on different issues we had discussed. That is the first thing is like that, how the conversion can be done, means how the IP protocol knows all the networks, and coming to next, how a connectionless forwarding will be done, and how the identification of each system will be done in a network with the IP address. So that also we have seen how different types of IP addresses which we have seen, that is class A, class B, and a class C. And in a IP address there will be a two parts, that one is a network part in beginning, and next will be the host part. So as we have seen like that, in class A, the first bit will start from 0, and remaining 7 bits will be for a network address, and remaining other bits, whatever is there in a 32 bits, will be for the host address. Why? Because so with a sample of means a large network can be covered, WANs, wide area networks can be covered with a class A. Again, class B will starts from 10. I think right, 10. So it will starts with 10, and then means another whatever 14 bits will be there, means 2 bytes will be taken for a network address, remaining 2 bytes will be taken for on a host address in a class B, comparative to with class C, where it will take 110, I think. So that will be taken into the consideration, starting 3 bits, and here only means 3 bytes will be taken as a network address, only 1 byte will be for a host address, where in a class C a maximum of 256 systems can be connected in one network, means in one LAN. Later on we can link that to the further networks. So that we had discussed in a last class. And coming to the next thing, that how the IP addresses can be assigned to the system. For example, if we take an internet to the BMSIT college, instead of giving internet connection to the each and every system of BMSIT, maybe around some 600 to 700 systems will be there of different branches, giving internet to each and every system by the ISP provider, that is internet service provider, who is in a class B, will become a problem. So what he will do, he will give a one particular connection, and later on so that will be divided to the different networks, means which will be taken. So in this particular way, subnetting plays a very much important role, where a LAN will be there, and I have told you that how a LAN will be taken with a class C IP addresses, and how one system will be assigned with a class B, and it will be the server will be shared with the class C networks using a subnetting mask. that I have told you. That means it is a means work will be there with an switch, whatever a router which will be placed, means which will be connected to that particular LAN. So how this particular algorithm, subnetting algorithm will work also, I have told you that how the subnetting algorithm will work. The IP address it will take, and operation, bitwise and operation will be done with a subnet mask. Then one number will be generated. That number will call it as a subnet number. If that number is same of the source number, then the destination is also there in this same network. Then no, what it will do, directly it will communicate with that particular host. Else if that subnet number is different, not of the source host subnet number, then the packet will be sent to the switch or on a router. So then router, it will in turn it will send to the further means switches or on a routers based on a forwarding table. So this thing we had discussed in a last class, and I would shown you one particular problem also in a subnetting, how a subnetting will be done from one network to the another network. Now we'll move with the other part of a lesson. Just 1 minute. Yeah, I'll share that PPT. Go then a window, right? Yeah, share this. Yeah, now you can see the subnetting algorithm. As I told you that in a last class we have seen D is equal to destination IP address, means whatever a destination IP address will be taken to the variable D for each entry is less than the subnet number, subnet mask, or next hop, whatever will be there. So each entry, one by one entry according to the forwarding table will be taken. D1 is equal to subnet mask and operation, bitwise and operation D, whatever a subnet mask is there, and destination IP address will be taken as an and operation. So then that will be the D1. If D1 is equal to subnet number, means whatever the source subnet number, it is same, then the next hop will be there in the same interface. It will be directly sent to the destination, else it will be sent to the router. So in this way, means the communication will be keep on sending. Coming to the next important concept of today's network, that is the classless addressing. Now instead of a subnetting, we are using the classless addressing. Why classless addressing? What is the need of the classless addressing? We'll discuss in this particular session, and I will tell you what is the importance of this classless addressing and how it can be done. Subnetting has a counterpart, sometimes called supernetting, but often called has a classless introdomain routing. So CIDR. So underline that particular word. Here afterwards, I will call this as an CIDR. CIDR means classless interdomain routing, and that means observe here what I mean to tell you now. Super netting will be taken into the concept by subnetting. Subnetting is a base. So with that subnetting only, we are taking a classless interdomain routing. What do you mean by this classless interdomain routing? For example, I'll tell you like this. Assume that a autonomous system is there, that is AS is there. Now what do you mean by this AS? AS is like this, one corporation or one organization, like our college or like one particular company. So where a different in a campus, one big area will be there. So that will be identified as one particular autonomous system. So how a routing will be done from one autonomous system to the another autonomous system, which will be shown publicly to the public internet. So for that concept, we'll call it as CIDR. Now coming to the classless addressing, address assignment efficiency will be there. What do you mean by this? A network with 256 hosts needs a class B addresses. Usually to say, if you are not using subnet concept or CIDR concept, definitely all the 256 systems in one particular LAN maximum you can take. So class B addresses is needed. So instead of that, that what happens for the efficiency, address assignment efficiency, what happens that 256 systems divided by the maximum capacity of a class B addresses are 65,535. How I can say this 65,535? For example, you may ask me the question. That is, in a class B, as I told you, that first 2 bytes will be for a network address, remaining 2 bytes will be for a host address. What do you mean by 2 bytes there? Maximum 256, 256. So 256 into 256. So 256 into 256, if you do the multiplication, then 65,535. So in that 256 systems, the efficiency will be of 0.39, almost all nearer to the 50%. So solutions. So for this, what we are going to use to solve this particular problem, we are using subnetting. Last class we had discussed. Only give a class C networks. Means when you use a subnetting, only class C networks will be there. Means with only one B class IP address which will be taken into the network more than 64 kilo host, means 64,000 hosts, which can be accommodated in a class B. So because of this particular reason, we can't allocate entire class B IP addresses to each and every system. Coming to the next. Now, problem with this solution means subnetting. Excessive storage requirement at the routers will be there. When you are going for a subnetting to solve this particular problem, yeah, subnetting is good. But what happens in a subnetting, how many LANs has it has been connected? Assume 3 LANs, if a router has been connected, storing the details of that particular LAN. So it needs excessive storage area in that particular routers. If a single site has, say, 16 class C network numbers assigned to it, imagine 16 class C networks, that is 16 LANs of 256 systems. Assume in different networks of class C will be assigned to a router. Every internet backbone router needs 16 entries in its routing table. So each and every LAN will have its own subnet number, means unique subnet numbers will be there, and there the IP addresses will be there. So how to identify that particular LAN with the subnet number? It will do. Which one? The router. That means in a router, apart from a forward table, the 16 entries should be there of that particular networks which it has been connected. This is true even if the path to every one of these networks is the same. So whatever you are going to take with the means each and means the router, whatever a switch or a router it has been connected, so everyone should be there in that particular means all 16 LANs should be there as an participative in that particular thing, right? Now coming to the next concept, if we had assigned a class B addresses to the AS, what do you mean by this? Autonomous system. The same routing information can be stored in one entry. Observe the difference here. For a router, 16 entries should be there. I will take a Mauser point here. Just a minute. It has been, yeah. You can see here, that is the 16 entries which you have to take for one particular router when you are using a subnetting. But when you are using a concept of AS, that is autonomous system, a class B address should be assigned, only a single class B address should be assigned, one entry address should be there, and it will be taken to others. Now you see here how the efficiency, number of hosts, number of values decreases. You can see here 16 into 255 divided by 65,536. Observe carefully. That will become a 6.2%, which is not so efficient. Are you getting my point? Very clearly I'm telling you. The efficiency, number of hosts and available addresses. The number of hosts will be, as I told you, that each router will have a 16 LANs. Assume each LAN will have around 255 systems. Now 16 into 255 systems, if you calculate, means multiply that, what will be the number for that? as I will tell you what will be the number for that means 16 into 255. Now 4080 almost divided by 65,536. So which will be around 6.2%, that is 0.06, which usage will be only that much, which is not efficient. So how to solve this particular problem with the CIDR, that is classless interdomain routing, how you can do. Now classless inter domain routing tries CIDR tries to balance the desire to minimize the number of routes that a router needs to know against the need to hand out addresses efficiently. Now again I'll come back. Now you see here CIDR, what it will do if you apply CIDR concept there, classless addressing concept there, the number of routes which the router is having, it will be minimized. It will be minimized, and only one efficient addresses will be taken. How to aggregate these particular routes means combining the particular routes. So that aggregation will be done using like this. Uses a single entry in the forwarding table to tell the router how to reach a lot of different networks. Breaks the rigid boundaries between the address classes. This is very much important. What do you mean by this? Assume, for example, one router is there of an BMSIT. If the router should know each and every department, for example, IS, CS, and MCA, mechanical, civil, like this, each and every, assume like this, 16 branches are there, just assumption, 16 branches are there. That means our router should know all 16 branches routes and its information, usually to say. But when you apply a CIDR concept, then you can take a concept with autonomous systems. Means you can combine the routes according to the block wises. Hostel separate, block C separate, and block A separate, block B separate. So like that you can do, where in turn there different branches may be there. So how to do this particular concept? So that is an important thing. Now you see one example I will tell you. Consider a site with 16 class C network numbers. We are already taken into the consideration, and our router is connected to 16 class C networks, LANs. Assume instead of handing out 16 addresses at random, hand out a block of contiguous class C addresses. What do you mean by this? Instead of giving the 16 different addresses, means whatever subnet addresses to that particular router, we'll give a block of IP addresses from this range to this range. How? I will come here. You can see here, suppose we assign the class C network numbers from 192.4.16 through 192.4.31. Observe carefully, 16 to 31. So how means continuous IP addresses you can keep on generating. Observe that top 20 bits of all the addresses in this range are the same. Now out of 32 bits, starting from 192.4.16 to 192.4.31, if you compare the 20 bits, all will be same. Very important concept I am telling. First you have to take the first IP address and the last IP address of one particular block, right? So in that particular range, what will be the common bits? First you have to calculate. Means what is the common bits out of 32 bits? For example, assume 16 bits will be common bits, 10 bits will be common bits, or 20 bits will be common. Now in this particular case, 20 bits will be common. You can see below, if you want you can convert and you can check it out, not an issues. If you convert 192.4.16 to the binary, and 190 one by one like that, 192.4.31 if you convert, in that 20 bits will be same, remaining 12 bits will going to change. Now we have created a 20-bit network number which is in between class B network number and class C number. Now note it down. Now what we will do, we for this entire block of 20 bit network created, what it has been created, for this we will assign one class B address, means internet. So all that group will get now. For all that group, this class P address will be the server, and where internet will be get by all this particular group, which is having 20 bits common C block, sorry, C class IP addresses. Now we'll move to the next part. Now you see, requires to hand out a blocks of class C addresses that share a common prefix. Sorry. Now I repeat. Now, how will you make a blocks? I will make a block of class C addresses systems, not depending on the systems, depending on the IP address range. That is, I will start an IP address, for example, 192.4. Whatever I told. How many common bits will be there? So if large block, if I want to do, the bits will reduce, common bits will reduce. How we will fix that common bits as a prefix? Now the convention is to place a/x after the prefix, where x is the prefix length in bytes. For example, the 20-bit prefix for all the networks, that is 192.4.16 through 192.4.31, is represented by /20. So whatever IP address you take in this particular block, it will be always represented. How it will be represented? It will be represented by /20, indicating that the 20 bits of this entire IP addresses block will be same. Then maybe each block, whatever a block you are taking, block will be different from one block to the another block. The common bits or prefix may be different. By contrast, if you wanted to represent a single class C network number, which is 24 bits long, we would write it. How we would write it? We'll write like this. If 24 bits common range, if you want to generate, so how will you write it? 192.4.16 IP address /24 bits, means it will be a common bit which will be generated of that particular block. Now you can see this particular diagram here. Advertise will be there here. 128.112.128./21. Observe here, /21 is very much important. The /21, whatever is there, this is a ISP provider. Now this is the customers. Now you see /24, /24, /24, entire /24. This is /21. Means this is the advertised group is a /21 group, autonomous different group, and this is all of one particular group customers. How this particular customers are one group? Why? Because all these customers are there in a range of 24. That is, the 24 bits of these IP addresses until this particular range, starting from 128 to 135, will be 24 bits will be same. So how it will be identified always? So whatever the bits is same range here, automatically the router will aggregate all this into a single route. It will send here. Then afterwards, here something will be taken into the consideration according to the address. That means it will be covered 24 bits, almost all out of 32 bits. So this group will be identified like that. So in this particular way, the classless addressing will be done. This is one of the important concept. Now I will stop sharing. Yeah. Now yeah, back here. Now any doubts you can ask now. So any doubts in a classless networking? It's open for discussion. It's open for discussion. Any doubts? Any doubts? Gudiya? 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 Ilva? Gudiya? No. Hello? Come on, respond quick. Any doubts?
No, sir.
No, sir.
See, I'll conclude like this. Classless addressing means the difference between subnetting and classless address. I will tell you very clearly. In a subnetting, what we will do, your router must know all the LAN networks, whatever is connected. Your router must know all the subnet numbers of that particular LANs. If 16 LANs is there, all 16 entries should be there. So a large memory will be used in a routers. So to suppress this, what we have to do, we will combine the roots of that 16 lands, for example, to blockwise to 3 blocks, or 2 blocks, or 3 blocks, or 4 blocks. How will you do this particular thing? So we will apply CIDR concept there, that is classless interdomain routing. How will you do? We will take a range of IP addresses, and we will, instead of making a LAN like that, we'll fix the IP addresses from that range to this range, means blockwise. So that entire block, you will tell, for example, in our block, assume BSN block, I will tell you MCI is there, IS is there, and a CS is there, civil is there. And for a civil, we will tell you start from this IP address, cover these systems. The next IP address will be given to the CS. The next IP address range will be given to the IS. The next IP address range will be given to the MCI department. That means starting from 192 range, below range, and we'll see out of all these particular terms, what is the common bits. Assume that the common bits will be of some 16. Now the /16 will be identified as a group of BSN block. So maybe that in A block, administrative block, it will be slash minimum branches are there. So there it will be taken as slash 24 or 20, like that. Maybe hostel, it will be taken as slash 20, like that. Different groups we will do, and according to the group number, prefix number, the router will send that packet. In turn there, the identification of the system will be done according to the systems. So in this way, the classless communication will be done in this particular network. Coming to the next concept, we'll go with the next concept. I'll share again. Yeah. After this, now we'll come to the next concept, that is different protocols which will be there with the IP protocol. Means to support the IP protocol, different other protocols will also be there. What are the different other protocols? ARP protocol will be there, address resolution protocol, and DHCP will be there, dynamic host configuration protocol, that is assigning a dynamic IP addresses in a network which our college is using now. Then ICMP, Internet Control Message Protocol, will be there. These are the sub protocols which will be used by IP protocol in that particular situation. Now we will see how this one by one protocol will work. Coming to the first one here, that is address translation protocol. What is this address translation protocol? Map the IP address into the physical address. This is very much important. That is mapping of the IP address, whatever is assigned to a system, with its physical address. I have told in the beginning very clearly that in a MAC protocol or in a network layer, the MAC address will be used. That we'll call it as a physical address. But in IP protocol, the IP address will be used. Then it's a work of an IP protocol to convert your packet to a frame. And what is a frame? It's coming, it should convert back to the packet. And the IP protocol should know all the networks which has been connected. For this, it is going to use ARP protocol. How ARP protocol will be used? To compare the physical address with an IP address. That is, if the physical address and IP address is matching, then it can convert that frame to the packet easily. That is, the table of IP to the physical address bindings has to be done by ARP. The router broadcasts a request who has till if the required IP address not in the ARP table. That is, who has 192.168.0.9 tell 192.68.0.1. That is, target machine, whatever will be there, means what is a router will do, means the router, to know how many systems it has been connected, one by one IP address it will call, and it will tell whether you are connected to me. Yes, I am connected. Who has this IP address? The particular system will tell, yes, I am having this IP address. So I am having this IP address means automatically the MAC address of that particular IP system will be noted in a router. So like this, it will be, who will tell, yes, I am having this. For example, assume 192.168.0.29, who is having, router will ask. Then automatically the person will raise a hand and assume, the system will raise a hand, it will tell, yes, I am having this, and my MAC number is so and so. Then your IP address and MAC number will be noted like this. For example, your USN number and your name will be to be matched with together. How will match? For example, if I ask you 1BY 19 MCA like that, who is this particular USN number? Somebody will tell, XYZ will tell, sir, it's my USN number. So assume that his name is XYZ. Now XYZ is having the USN number so and so. You can assume the USN number as IP address, the person name as a physical address. So like this, the matching will be done, the entry will be there in one particular router. So whenever the IP addresses will come, means the packet will come with an IP address destination, then the ARP means while converting to the frames, the ARP protocol will will tell, it will take out that IP address and it will put that MAC address, means physical address in a frame instead of IP address. Why? Because the other system, host system which is connected, will check only the MAC protocol. That is which I have told you in a data link layer. To do this particular process, this ARP protocol will be used. So this is other one important concept. Coming to the next thing, that is host IP configures. So host IP configurations, how it will be done. Most host operating systems provide a way to manually configure the IP information for the host. You can go there, you can see the screen which I have shared. You can go there and you can check the network information, whatever is there. So you can go there, go to the properties of that particular network, and manually you can set the IP host address and default gateway address also. Drawbacks of manual configuration: a lot of work to configure all the hosts in a large network. Configuration process is error prone. Assume that there are 1,000 together systems are there. Each and every system manually you have to allocate a IP address to that. It will become a problem. Because of this particular reason, automated configuration process is required using DHCP protocol, that is dynamic host control protocol, which dynamic things will be allocated. How? I will tell you like this. In our college, you take an example of our college. In a BMSIT college, assume that there are around 3,000 students are there, and all the 3,000 students needs an internet. Manually if you do, for example, manually if you do, for each and every student, 3,000 students, the ISP provider convergent should give the IP address. Then it will become a problem to him how to allocate the 3,000 IP addresses. It will be waste. For example, at one particular moment of time, only 600 students will use the internet. Remaining members may be sorry, maybe absent, maybe in a class, or maybe somewhere else. So only 600 members at one particular period of time will use the internet. Instead of that 600 IP addresses, giving 3,000 IP addresses is lost to the ISP provider. That is the one important concept. Then what he will do, he will make a pool of 600 IP addresses. One pool he will make, one buffer he will make, and DHCP protocol will be there. For example, you will log in first. Assume, enter your username and a password, log in. Your router is identified as you are the BMSIT icon. Once it has been identified, compared to your MAC address, then what it will do, it will connect you to the internet. That means out of the pool, one IP address it will take, it will allocate to you. Like that, it will take one IP address and it will allocate to you at that particular moment. Once if you logged out, means if you tell, yes, I will log out. Once if you logged out, that IP address will be released and it will be thrown back to the pool. So in this way, the DHCP protocol will work. That is, DHCP server is responsible for providing a configuration information to the hosts. Means it will provide IP addresses. There is at least one DHCP server for an administrative domain. DHCP server maintains a pool set of available addresses. That is, one administrative domain will be there, means our server system in a data center will have this DHCP concept. Already it has been programmed like this. You take this pool of 600 IP addresses. Whenever whoever connects to the internet, you allocate one IP address. When he releases, come back to the pool. So in this way, the DHCP will work. Newly booted for attached host sends a DHCP discover message to a special IP address that is called as 255.255.255.255. Means it will ask the DHCP server that you assign me one IP address. DHCP Relay agent unicast the message to DHCP server and waits for the response. So it will send to the DHCP server, who will send the relay. DHCP relay will be sent. Then after sending that, if after doing the authentication, everything, this process will be done. This is very much important. In our college, first your identification will be done. Once you are authorized as a BMSIT user, then only you will be given a connection. Means your message will be sent to the DHCP discover. Then afterwards, DHCP relay agent will send a DHCP server that okay, you can assign him a IP address from the pool. So later on, it will be assigned to you. So in this way, the DHCP will be worked. Coming to the next protocol, that is Internet Control Message Protocol, ICMP. What is the work of this ICMP? Defines a collection of error messages. For example, some router error messages is there, link failure is there, a destination is unreachable, somewhere a loop is there, then TTL has reached to 0, means time to leave of when a packet has reached to 0. All these information should be given to the source. Who will give this information? As in a video in a beginning, you have seen that some packets will be moved with an ambulance sound with a red light. So that ICMP protocols, means packets will be there, agents will be there. They will be keep on rotating towards the topology of a network. So how these things? So defines a collection of error messages that are sent back to the source host whenever a router or a host is unable to process an IP datagram successfully. What reasons? Destination host unreachable due to link failure, as I told you. Reassembly process failed, means hanged out. TTL has reached to 0, means the packet is in a loop. IP header checksum is filed, some error is there. So due to that particular reasons, that reason should be known to the source or a destination. It should tell something is happening there. Who will tell? ICMP protocol agents will tell. ICMP redirect from a router to a source host with a better route information. So in between, the ICMP agents will tell their route failure is there. You make a new route. It will intimate either the router or a source. So you make a new route to the destination. This is a work of an ICMP protocol. All control messages, all whatever error messages will be there, it will be controlled by ICMP protocol. In this way, ICMP protocol will help IP protocol to manage the route between or packet between source to destination. So this is the other protocols, ARP, DHCP and ICMP protocols, which is supporting the IP protocol. In the next coming class, we are going to discuss we are going to discuss with the routing, the last service of the IP protocol, how a routing will be done from source to destination, which algorithms in real time the IP protocol will use to transfer a packet from source to destination, and how the route will be maintained from different networks through and to reach the destination. So this is a very important concept which will comes in advanced internet working. We'll go with chapter number 4. Routing, full information will be there in there, and we'll go through that particular chapter. Combining third chapter and a fourth chapter will end the IP means module 3. So module 3 is somewhat big. So module 3 will be end with that particular concept. And for IA test 2, module 2, half of the module 2 and module 3 will be there for IA test 2. Anybody, any doubts is there with you can ask. Any doubts is there? It's open for discussion now. You can ask. Any doubts is there? Any doubts is there?
No, sir.
Any doubts? If you are unable to ask in a group doubts, personally you can call me, you can ask me. Otherwise, you can see this video in a YouTube channel. Even though you are getting a doubts, I will re-explain you, not on issues. So you go through once again, then you can understand very clearly the classless addressing concept. Today, what I told, that is an important concept for today's session. Okay, thank you very much
Thank
for
you, sir.
listening. Thank you, Pa.
Thank you.
Thank you.